Hey everyone, and welcome back to The Explainer. Today, we're breaking down a genuinely staggering vision for our technological future, straight from one of the most legendary figures in computer science, Google's Jeff Dean. In a fascinating recent discussion, we were handed a roadmap of what happens when artificial intelligence doesn't just improve by a few percentage points, but takes a mind-bending, million-fold leap in computing power. We are going to unpack exactly what that means for the architecture of AI, the future of open source models, and how machines might very soon become endless lifetime learners. Okay, let's dive right into this, because right now, there's this massive fear echoing throughout the entire tech industry, the fear of hitting a data wall. For the past decade, AI has gotten smarter primarily by, well, reading the internet. But what happens when it's read absolutely everything? Are we literally running out of data to feed these incredibly hungry systems? It's a critical question, and it's driving some of the most radical shifts in how we build AI today. So here's our roadmap for today's explainer. 1. The AI data crisis. 2. The inference paradigm shift. 3. A million-fold compute leap. 4. Lifetime AI and agents. And 5. The lightning round. Section 1. The AI data crisis and hitting the wall. This is the immediate hurdle AI developers are grappling with as we speak. The whole foundation of our current AI boom is text, right? Vast, massive oceans of human-generated text. But we're facing a very real data bottleneck here. If the current trajectory continues, we could actually exhaust the entire supply of high-quality human text available for training. So the crucial point is this. If we run out of human text, how can AI possibly keep growing? This bottleneck is forcing researchers to urgently figure out new ways for AI to learn, ways that don't just rely on ingesting more books, articles, and websites. Section 2, the inference paradigm shift, and how we actually use AI. We are seeing a fundamental architectural change in how compute power is actually being spent under the hood. We're shifting to a world where a massive 90% of compute is dedicated to inference and only 10% to training. What does that actually mean for us? Well, historically, the massive heavy lifting was training the AI. But now, inference, which is the AI actually running, thinking, and generating responses for billions of users, is completely taking over. The real computational puzzle of the future isn't just teaching the model, it's running it efficiently at an unfathomable global scale. And because of that huge shift, the very life cycle of AI is totally transforming. In the old paradigm, you had a really strict split. You did your massive pre-training, then you did your fine-tuning or post-training, and then the model was essentially frozen. It was just a static snapshot of intelligence. But the new paradigm, it's a blended, continuous flow. Actually, scratch that. It's more like a living system. The end of this rigid pre- and post-training split means we're moving towards systems that don't just stop learning the moment they're deployed. The lines are totally blurring to make AI far more dynamic. Section 3, a million-fold compute leap and the hardware reality. Now, this is where Jeff Dean's vision gets truly staggering. The sheer horsepower making all of this possible. 1 million times. We aren't talking about processors getting, 20% faster next year. We're talking about preparing the architecture of artificial intelligence for hardware and data center leaps that will provide a 1 million-fold increase in compute power. When you have 1 million times more compute at your fingertips, the constraints on what you can build just entirely evaporate. You stop optimizing for pennies and start building entirely new economies of intelligence. But you don't just use that compute to make one giant, unapproachable brain. You use it to democratize intelligence. It's basically a 3-step process. Step 1, you use that massive compute scaling to train bleeding-edge colossal models. Step 2, you use a technique called knowledge distillation, which essentially takes the profound reasoning of that giant model and compresses it. And step 3, you end up with supercharged open models. This means the million-fold leap at the top eventually trickles down, creating incredibly potent, efficient models that everyday developers can just run on their local machines. Section 4. Lifetime AI and agents, the endless learner. So with that power decentralized, what do these models actually do? Well, we move from static tools to endless learners. If you track the operational focus of AI across time, it's wild. In the immediate fraction of a second, just 1 millisecond, engineers are solving the attention problem, ensuring AI can perfectly recall and process massive context of information instantly. Expand that to an hour, and you have AI executing complex multi-agent workflows, where different AI personas collaborate to solve really complex problems together. But stretch that out over years, that's when you reach the ultimate quest, achieving lifetime AI. Models that retain their memories, adapt to you over decades, and continually evolve.
When you combine this lifetime learning with multi-agent workflows, the applications become completely mind-bending. We're talking about AI not just writing code, but generating full operating systems on the fly. We're looking at AI natively running and simulating entire interactive environments, like the classic video game Doom, purely inside its neural network without a traditional game engine. No way, right? And it's all powered by complex multi-agent coordination. We're moving from AI as a chatbot to AI as an active, continuous digital ecosystem.
Section 5, the lightning round, from cosmic rays to Chuck Norris. All right, let's jump into the wildest, most human, and honestly cosmic elements of running tech at this scale. When you build giant data centers to house all this million-fold compute, you don't just battle software bugs, you battle the universe. Literally. High-energy particles from supernovas deep in space create cosmic rays that bombard the Earth, and occasionally, these invisible rays strike a memory chip in a massive data center perfectly, flipping a single bit from a 0 to a 1, causing bizarre and unpredictable disasters. At Google scale, cosmic rays are a completely normal operational hazard you just have to engineer around.
But the hardware isn't the only thing with a legendary status here. In the developer community, Jeff Dean's coding prowess is so revered that he's basically the Chuck Norris of computer science. There's an entire subculture of internet jokes about him. For example, when Jeff Dean pushes code to the repository, the code doesn't compile, it just surrenders. It's a great reminder of the deep, quirky human culture driving these massive technological leaps.
Yet, even the legends have moments of deep humility. In the discussion, Dean admits to a major miscalculation: healthcare AI. Years ago, the expectation was that AI would rapidly and easily revolutionize healthcare systems. But the reality of messy medical data, strict regulations, and really complex institutional workflows proved vastly more difficult to navigate than pure computational math. It's a vital lesson. Transforming the physical human world is much, much harder than scaling data centers. And of course, no deep dive into the mind of a legendary programmer is complete without settling the ultimate, age-old developer debate over text editors, Vim versus Emacs. It's the purist's choice versus the highly extensible environment. I won't spoil exactly where the allegiances lie, but it just goes to show that even when you are planning the architecture for a million-fold leap in global artificial intelligence, developers are still going to argue passionately over how to type text onto screen. So we've covered the data wall, the massive pivot to inference, open source distillation, and the incredibly sci-fi frontier of lifetime AI. The scale of this transition is completely unprecedented. So I want to leave you with this thought. In a world where AI hardware scales by a millionfold and the machines themselves become endless lifetime learners, how will you prepare? How is your industry going to adapt to a leap of that magnitude? Thank you so much for joining me for this explainer, and I'll catch you in the next one. Keep learning.